What I'm going to talk about is scaling infrastructure access. Because sometimes when people ask me, like, where do you work? And I explain to them that Teleport is a solution for accessing infrastructure remotely. The obvious question is like, well, we had data centers for a really long time. Didn't we already have the technology to access them remotely? But the world changes. Organizations scale. We're processing more and more data. And the early founding team of Teleport, our engineers who started this company, like they came from hyperscalers, from organizations that operate at a scale that has never been seen before. And as you scale, access breaks. It needs to be reinvented continuously. And the lessons that we've learned by scaling access are what I'm going to share with you right about now. All right? Let me start with the obvious question, like what is access? Because the word access is used in many different contexts, with different companies, on different front pages, on different websites. And for the purposes of accessing infrastructure, I would say that this is what access means. It consists of four kind of logical components: connectivity, authentication, authorization, and audit. Connectivity is probably the most obvious thing. If you're accessing a computing resource, infrastructure component like database, obviously you need to be able to send and receive data packets, hopefully encrypted, to and from that resource. The second component of access is authentication. You have to prove that you are who you claim you are. Without it, access shouldn't be granted. And the third component is authorization. So what are the things you're allowed to do? Are you getting full access or read-only access? Those are very common types of authorization. And finally, what's happening right now? The real-time visibility of what is going on, as well as historical evidence, what happened and who's responsible. So that's audit. That's the fourth pillar of access. So there are open source projects and companies and solutions that do all of these different components of access. But it's actually really hard to find a solution that does all four. It's one of the reasons why we started this company. Now we're all on the same page. We understand what access means. It means these four things. So therefore, if we're scaling infrastructure access, we need to scale connectivity, authentication, authorization, and audit. The next question might surprise you. What is infrastructure? Well, infrastructure is not just servers. I would say that infrastructure means these three things. Because we use computing infrastructure to do computing, to process data. And this dance of computing is a triangle of three actors. You have hardware, then you have software that we're running on that hardware, and we have peopleware. So those three components, they need access. Therefore, scaling infrastructure, it means that it's a process of continuous scaling of connectivity, authentication, authorization, and audit, and it needs to work for hardware, software, and peopleware. If you think about like attack vectors, what or who is getting attacked, it's hardware, software, and peopleware. They can all be attacked using different attack vectors. This is what this talk is about. That was a really long introduction, but let's move forward. So, why access becomes problematic as we scale software? Let's zoom just in a software component. This is really complexity piece that I'm covering. Just imagine your typical computing environment. It could be on AWS, it could be on some bare metal servers in your own data center. But it's easy to visualize all of these software components lined up in layers. You have bare metal at the bottom sometimes. Then you have an API to control that bare metal hardware. Then you have virtual machines. Then you have APIs to control machines. Then you have containers. Then you have containerization orchestration layer like Kubernetes. Then you have container registry where containers come from. Then you have MongoDB, Jenkins, the web UI for MongoDB, and list goes on and on and on. And every single layer, and if you count your environments, you probably come up with dozens of layers. And every single layer listens on a network socket, has its own authentication, has its own RBAC authorization, has its own audit, has its own config file, has its own configuration file format, and requires expertise on your team to set up. So as you scale software and you're adding layers, the access becomes more and more complicated. Now, even if you learned how to secure your software, you have to repeat it many times over because your infrastructure continues to grow. You have AWS East, you have AWS West, you have Azure in Amsterdam, and you keep adding and adding and adding as your organization grows. So the access becomes more complicated. The access needs to be reconfigured. And as I said earlier, it represents risk because you can make a mistake, and it's also very painful, simply because it's a lot of work. But your organization is also scaling. You have interns, you have external contractors, you have different levels of engineers, you have dedicated security team. People join and leave organization almost on a daily basis. Everyone is working from home now. Everyone is using their own devices. So access needs to evolve, and access needs to scale as your peopleware scales. And here's an interesting stat that I'm showing. It's a very recent infrastructure access report conducted by an independent agency, where they said that 76% of organizations cannot guarantee that their former employees, engineers who used to work there, can no longer access production environments. If you were to ask me, this should be on CNN. Like everything is moved to the cloud, and it's accessible. Like 76% of your data probably is accessible by basically strangers. And here's something that Kevin mentioned earlier, that security and productivity, they actually at conflict with each other. It's true not just for infrastructure assets, it's true for everything. Like when you go get groceries, you get out of a car, you get to your house, and the door is locked, and it's raining, and you need to put things down, and you need to open, and if you have 7 locks, then you're going to be 7 times as wet if you only had 1. And if you're an engineer operating in a complex environment, then security constantly gets in the way. And the thing about engineers is that it's really hard, and I would say probably impossible, to force them to do something that they don't want to do. Think about how infrastructure in the cloud is getting provisioned. It gets provisioned through, I don't know, like Ansible script or Terraform. Well, who wrote those scripts? Engineers did. If they did, they can plant any backdoor they want. And they do in 57% of organizations. Here's another industry stat, that 57% of organizations that were surveyed in that report, they said that they have adopted a security solution, but it didn't gain traction with their employees. Think about it, what it actually means. It means you have a multi-tenant building, and you put a new door for that building, but 57% of tenants not using that door. What does it mean? It means there is not a door. It's a backdooring situation, and you need to be aware of it. So now, how do we scale? How do we deal with these challenges? Before I continue, I want to point something out, that most successful attacks follow the same pattern. First, a human error is exploited. Someone clicks on a link they're not supposed to click on, open an attachment they're not supposed to open, basically did something they're not supposed to do. It's not because people are bad, that is simply because people are people. We're very unreliable, moist robots, and we will do people-y things. So we're going to be borrowing from a previous presentation. And once an attacker exploits human error, establishes a foothold into your organization, the second thing they do, they pivot. They go after adjacent systems that they try to get in, and they grow, and the blast radius increases. So most attacks follow this pattern. And we all read tech news, hacker news, and so on and so forth. And it's the same story almost every week. Someone is attacked, and this is actually what's happening. So what do we do as we scale? Well, first, let me make an observation. I think it's safe to say that we cannot eliminate human error. It's the same thing as with kind of ACC RAM design. So yeah, RAM is pretty reliable, and yes, we like to think that we hire reasonable people, but as you scale and as you grow, then probability of someone making a mistake at this particular moment goes up and up and up. And you can purchase and install more and more secure solutions to bring that probability of human error down, but then you continue to scale and it goes back up. So it's this race, like scale, introduce, like Scale, by its nature, increases probability of human error. What do? You have to design your access solution to not rely on human errors. And how do you do that? Well, human errors usually lead to credentials being stolen, some kind of secret. Maybe it's a password on a sticky note. Maybe it's an API key or a browser cookie, a session token. Some kind of secret is leaked as a consequence of human errors. So therefore, to eliminate the consequences of these errors, move away from all secrets. Make sure that your infrastructure is accessed based on true identity. And true identity is identity of people, of machines that exist in the real world. So what does it mean? It means that you should be using things like biometric, TPM on a client, HSM on a server. So these things, again, physical attributes. They are not data. They cannot be stolen. The private key on a TPM is not readable. It's not possible. So if there is a human error, no one will be able to get it out. It cannot be copied. It cannot be sold in darknet. It cannot be stolen, duplicated, uploaded, downloaded. So that's the first thing. See if you could eliminate secrets in your organization. From a teleport perspective, the presence of a secret anywhere in an organization is a vulnerability. You can encrypt it, you could rotate your secrets. You are lowering probability, but it will go back up as you scale. For this reason, the existence, the presence of a secret is a vulnerability. So the question then, if you're getting rid of all the secrets and you're using physical attributes of humans and machines like biometrics, how do you transfer that identity into your infrastructure to make authentication and authorization decisions? And we're not aware of a better technology for this than certificates. Yes, certificates are secrets, but they are temporary secrets. They expire quickly. How quickly? That's up to you. You could configure a certificate to be expired after first use. Certificates are also portable because it lowers your operational overhead, because there are two primary certificate types are X509 and SSH. So if your access solution issues certificates for everything you need, then all of your infrastructure is covered because certificates are supported by almost everything. They also can be pinned to a context when this particular certificate is valid. For example, on a client IP address. Next up is you have to eliminate access silos. Simply because as you add more software, more hardware, more different data centers and regions, you end up with different silos with different sources of truth. So consolidating policy in one place, that allows you to scale very cheaply. Another thing to keep in mind when you think about scaling access, in addition to not having any secrets. So if you imagine the presence of a secrets, your secrets population, that's like a surface area for an attack. And another surface area is time. So if someone has an access in your organization, because policy says that this person needs to have access, ask yourself, are they exercising that access right now? And if not, then the access should be revoked. And you do it with something that's called access requests. Meaning when a person is trying to access sensitive resource, make sure that the access could be temporarily elevated for the duration of the need for that access, and then dropped. What it allows you to do, it allows you to state at any particular moment that nobody at this particular moment has access to something critical. So again, that shrinks the surface area of an attack. Another very popular access silo is machines versus humans. So if you think, for example, of very valuable data that you might have, that data probably lives in a database. There's a database table. And now think about how, like all these possible ways how that data could be stolen. So if your engineers are doing like SSH, they could SSH into that machine, or they could use like MySQL dump command. They can go through a web UI, but the point is there are many different attack vectors. And half of those are machines talking to this database. You might have a compromised microservice. You could have your backup script. All of these things, they also need access. So if you have completely different policies, if you have two different things that you need to tweak to enforce policy, then again, you are not scaling properly. Consolidate and make sure that you have a single source of policy for machines accessing data as well as humans accessing data. And next big question is, well, what if, let's just assume that we've done everything right, but an attacker still managed to get in somehow. And they now have a foothold in your organization. Maybe because you have a compromised WordPress, maybe running somewhere. How do we prevent them from going after adjacent systems? The answer to this has been known for a very long time. It's called zero trust. Zero trust, I believe, came out of a paper that Google published a long time ago. It basically states that you should not trust the network. Every computing resource, every server on your cloud or in your own data center needs to be designed as if there is no perimeter. It needs to be designed if they're running on a public network. Think about Tesla, for example. Every Tesla car is like a rack of servers on wheels. There is no perimeter, and it's pretty secure. So that is a true zero trust architecture. Another one is probably in everyone's pocket. Like this thing is just as powerful as a rack of servers maybe from 20 years ago. It has a public IP address. It's like we're not sitting behind VPN, like there is no firewall, yet it's secure. Why is it secure? Because it implements zero trust. It doesn't trust the network. So make sure that you use solutions like Teleport that follow this idea. And finally, avoid having many different audit logs. Because as you scale, as I said, you're going to have more and more different regions, more and more cloud accounts, more and more software. You don't want to have many different places to look for problems. So having unified audit is really important. And now let me remind you also about this conflict that exists between security and productivity. And if you make your organization really, really hard to be a successful software engineer at, you will end up with a security fear where your own developers will be building backdoors that you're not even aware of. It basically means that your infrastructure is only secure if the engineers who work there, who work at your organization, actually love their access tools. So it's really, really important for security because I totally agree that security is mostly about people. And for that to be true, the access solutions, they need to be easy to get started with. That's actually why we put a lot of effort to make sure that Teleport is actually a single binary. And you know what actually didn't work? We made it a single binary that doesn't have any dependencies, and yet people want us to stick it into a Docker container, which is really, really common. But OK, so we did, so now we can run it inside of a Kubernetes. We also believe that security, you can only be secure if you are using open solutions. And there are different reasons for this. Like one of them is, like if you're an engineer and you're about to execute git push into a public GitHub repository. So theoretically, it means that in about 5 seconds, 7 billion people, theoretically, 7 billion people will know if you did a good job. For this reason, engineers who build in the open, they tend to produce higher quality work. Also, it keeps us accountable because everything we do is out there. So anyone who's even smarter than us can just go and audit Teleport code, for example, line by line to see if we're picking the right hashing function over here or if we're not using any compromised libraries. But it's not just so much about developing in the open. It's also important to collaborate. So we love interacting with Teleport users, with all of you, with Teleport customers as well. So therefore, I love to think about what we're actually doing here as a collaborative effort and with many, many security teams of best companies in the industry codifying industry best practices. So to sum things up, what does it mean to scale infrastructure? Well, the first thing you have to do is to eliminate consequences of human error by adopting secretless security model. This is, by the way, not just true for Teleport and not just true for infrastructure access. This is true for security in general. Eliminate, make sure that you're immune to human error. Prevent pivots by adopting true zero trust. Do not ever make any assumptions about the network. Don't trust the network. Eliminate access silos, but making sure you have a single source of truth for policy and single source of truth for audit. It's really important. It becomes more and more important as you scale. Prevent the situation of having security theater, which is, again, it's resonating strongly with the previous presentation that you just heard. Simply by putting a bunch of no's, you are not making yourself more secure, because your engineers will find a way to gain access if they need to. And finally, to build trust with vendors and solutions we all use, let's all make sure we use open source. That's how you scale infrastructure access. Thank you for being here today.